Hello, trig class. It is Veterans Day, 11/11/15. I hope you were able to thank someone for serving our country today. Our topic is double angle IDs. I was looking at your list, your trig IDs, and it was looking a little slim. So we're going to add to it today. There was a commercial I grew up, and everything was doubled because it was about double mint gum. And all of us knew this jingle, and it still pops into my mind, unfortunately, today. So I'll share it with you.
A double pleasure's waiting for you. A double pleasure from double mint gum. A double great feeling, making you realize double is the one for you. Double fresh, double smooth, double delicious to chew. A double pleasure is waiting for you. Double mint gum. A double pleasure is waiting for you. Double mint gum.
Okay. So you can see why people of our generation are a little strange. We grew up with that in our heads, so it's pretty scary. It was always a set of twins in the commercial just like that. Well, the twins we're going to look at today are angles. Oh yeah, I think that product is still on the market, so somehow it survived that commercial era. We're looking at double angles today, and the double angle means, say I wanted to know the sine of twice of an angle. So let's do some review over here in the corner, sneak over here, and sine of a plus b is old news, so I'm going to write that out. It's sine a cosine b plus cosine A sine B. So there we have that. And that's going to help us with the sine of 2A, because I'm going to think of the sine of 2A as the sine of A plus A. So when I do that, can I not use this formula over here? So it just so happens that this is my A, and my B is also A. So when I use this formula, when I get to A, I'm going to use A, and when I get to B, I'm going to use A. So let's see what comes out. I'll work over here where we can see the formula. So sine of A plus A, using this form, this pattern, I get sine A cosine A, because it's sitting in my B spot, plus cosine A sine A. Alright, let's clean it up. Sine of 2A, we'll call it. In this we can rearrange the commutative property for multiplication. Allows us to take two things that are multiplied together and switch their order. So, just switching. Now, this term is the same as this. So what is sine A cosine A plus sine A cosine A? See if you can put that answer there. Are you writing 2 sine A cosine A? It's like 1x plus 1x is 2x. Well, one of these plus one of these is two of these. This is the sine of a double angle. So there we have it. Add that to your trig ID list, and if you haven't added the 4 sum and difference trig IDs to your ID list, please do that first. Alright. Well, that's not enough, so we're going to discuss the cosine of 2A. Before I write that down, I'm going to remind you that the sine of an angle, sine squared of an angle plus cosine squared of an angle equals, of course, 1. Alright. Let's look at cosine of 2A. And once again, I'm going to use the same strategy. Cosine of A plus A. So over here, let's remember what this cosine of A plus B is from our last lesson. So the cosine of A plus B is going to be cosine A cosine B minus sine A sine B. So how does cosine of A plus A turn out? See if you can do what I did above with sine of 2A to tell me what the cosine of a double angle is. I will write it quietly while you write it without looking. All right, did you replace B with A as well as A and get cosine A minus sine A sine A? Cosine A times cosine A is cosine squared A, and sine A times sine A is sine squared A, and there's a minus sign in between. So that is our cosine of 2A identity, but not totally. So I'm going to go over here and make a little box for cosine of 2A and put in it cosine squared A minus sine squared A. So that's one form. It actually has more than one form that pops up that we should use. So here's my cosine of 2A box. I'm going to collect those formulas. Alright, so from this one, the Pythagorean IDs up here that we reviewed, it's going to help us rearrange this one for another version of cosine of 2A that is useful. And I was looking at this, and if I preferred to work all in sine, the Pythagorean ID could help me do that, because I know the rearrangement of that, wherever there's a cosine squared of an angle, I can replace it with 1 minus sine squared of an angle. So that's what I'm going to do. So instead of using cosine squared, I'm going to put 1 minus sine squared A. So go ahead of me and clean up that mess. Simplify that. These parentheses are not necessary. I'm going to drop them and combine what's left. 1 minus what's sine squared A minus sine squared A. Minus 2 sine squared A. And that's the next trig ID to put in our cosine of 2A box. So back over here, get 1 minus 2 sine squared A. All right. One more for the road. Let's go back to this one and say, well, I didn't want to work in sine, I wanted to work in cosine. So is there a way I can get rid of this and have an expression in all of cosine? Well, of course there is. The Pythagorean ID could also be rewritten so that sine squared is going to be equal to 1 minus cosine squared. So I'm going to do that instead. So coming off of this box, I'm going to write cosine 2A, equals cosine squared. I decided to work in cosine. The minus sign is a little pesky, but nothing we can't handle. But just remember, when I replace sine squared with more than one term, an expression, that negative sign will affect everything behind it. So that's why the parentheses are there. So when I get to sine squared from the trig ID, there you go, it's going to be 1 minus cosine. I'm sorry, sine squared, yeah, it's 1 minus cosine squared. All right, so cosine of 2a equals, this negative sign can be distributed now. On your last test, I was mortified to see sometimes this step didn't happen. So please note, when there's a negative sign in front of an expression, it affects everything behind it. All right, cosine of 2a equals, could you clean that up, please? Are you getting 2 cosine squared a minus 1? All right, so that's the last one for our collection. And we get 2 cosine squared a minus 1. So we have 3 forms for the cosine of a double angle, and we end up using the one that is easiest to use in the situation we find ourselves. All right. We will not have a lot of work time tomorrow in class, so I'll just show you one way we can use this and see if I can get you to do something similar tomorrow in our work time. We're going to have some guests in class, so our work time will be short. In our normal work time will be short. I'm going to solve this trig ID, and it has a double angle in it. So 2 cosine x plus sine of 2x. I'm going to go back to my new trig ID up here, this one, and replace sine of 2x with 2 sine x cosine x. Now you are in solving equations, trig equations land where you're familiar. We solve this by factoring the common term. When I factor out a cosine, what remains in this term? Let's take out a 2 as well, because they both have a 2. So what remains when I factor out a 2 cosine x from this one? Well, it takes out or removes, factors out the whole term. And what's left in here? Sine x. When I set these equal to 0, that's why I factored it in the first place, so I can do that. And where it is, divide both sides by 2, and you still get 0. Cosine x is 0. That's the first coordinate. Happens at pi and 3 pi over 2. And sine of x equals minus 1. Also, is it right? Yeah, at 3 pi over 2, so I don't need to write it again. So let's just include all the answers. All right, pi. Oh, look, those are across from one another. Are they? No, they're not. So pi's over here, and 3 pi over 2 is over here. So pi plus 2n pi is one set of answers, and the other set is 3 pi over 2 plus 2n pi. All right, that's all for tonight, or today, whenever you're looking at this, and I will see you in the morning. Have a good rest of your day. Bye for now.